I have a lot of monopoly information to convey before having students do some application exercises related to monopoly in tomorrow's class. So I wanted to finish the wrap-up by talking about the one problem on the Module 4 wrap that a lot of students and a lot of teams needed more than one attempt to get right. So let's think about this problem. This is number 27. I had, as you answer question 15, I didn't change that in the directions. That was just a typo. Anyway, consider the game summarized by the table below as you answer question 15. The dollar amounts indicate firm annual profits for each combination of strategies. For example, if firm A prices high and firm B prices low, that would be here and here. Firm A loses 50 million and firm B earns 500 million in profits, and so on. All right, so how do we think about a game? Well, notice this is a game. We have players, firm A and firm B. We have possible actions, simplified to be price high or price low. Each firm has the same set of possible actions. That isn't always the case. Some games that's different. And then finally we have this payoff matrix. I like this format where the upper right payoff goes to the upper right firm for the combination of strategies of that cell in the grid, and the lower left corresponds to the payments to the firm, to the player on the lower left. Anyway, so how do we solve a game? The way you solve a game is to invoke the principle of Nash equilibrium. An outcome is a Nash equilibrium if at that outcome, at that combination of strategies, no player has the incentive to change their action given the actions of the other firm. So let's just think about how this game plays out, and then I'll come back and circle around and show you that the predicted outcome is the single Nash equilibrium. This is a prisoner's dilemma, an example of a prisoner's dilemma, and I'll talk about the elements of that. Basically, to be a prisoner's dilemma, both players have to have a dominant strategy, and the combination of the two dominant strategies leads to an outcome, the Nash equilibrium, that is different from the best available outcome for the players in the game. All right, we'll see a lot of these, so that'll sound more intuitive by the end of the unit on oligopoly. All right, so let's think about it from firm A's position first. So let's suppose firm A thinks firm B is going to price high. What should A do? Well, firm A could price high and make 300 million. These are just rational, self-interested people, firms, and there's no payback. This is a one-shot game. There's no future. So given that firm B is going to price high, if firm A thinks firm B is going to price high, firm A could price high and make 300 million, or they could price low and make 500 million. So if they think firm B is going to price high, firm A is best to price low. Well, what about if firm A thinks firm B is going to price low? Well, firm A could price high and make 50 million in losses, negative 50 million, or firm A could price low and make a positive 100 million. And that's a better play for them. So if they think firm B is going to price low, firm A is also going to price low. Notice that firm A has a dominant strategy to price low, and that's because no matter what firm A thinks firm B will do, the best strategy is always to price low. And it's a symmetric game, so when we go through that reasoning for firm B, we see that firm B has a dominant strategy to price low. Well, they're both pricing low. We're going to end up where both firms price low. The single Nash equilibrium is where both firms make $100 million. And that's not small potatoes, but it's a lot smaller than the possible 300 million if they could somehow agree to price high. The problem is agreeing to price high is collusion. That's illegal, so it's hard to make an enforceable agreement to do something illegal, because somebody violates that agreement, you go to the authorities, you're in trouble too. It's like you read those police reports. Somebody called police to report that another person had stolen their meth. Well, guess what? You're in trouble. So going to the authorities doesn't help. All right, so let's just verify that this is a Nash equilibrium, and the only Nash equilibrium. I'm going to change the color pen, change it to blue. Now, to find a Nash equilibrium in a game, if both players have dominant strategies, it's easy. Both play their dominant strategy and it's done. But sometimes you get games where you need to go cell by cell through the game to see if there's a Nash equilibrium. So let's just do that for practice. What about firms both pricing high? A lot of you, I bet, suggested that was the Nash equilibrium. Well, let's think about that. If firm A prices high, would firm B have any incentive to change their action? Well, yes, they would. Remember that the Nash equilibrium, an outcome is a Nash equilibrium if, given what other players are doing, no player has an incentive to change their action. Well, that's clearly not the case here. If firm B thinks firm A is going to price high, firm B would rather change its action to price low and get all the sales and get the profits. And the same holds, actually, both would rather defect here. Now, let's check the combination where firm B prices low and firm A prices high. Well, given that firm B is pricing low, would firm A be happy to stay pricing high? No, firm A would want to change its action to also price low. Firm B is plenty happy, but firm A is not. So all you need is one player that wants to change its action given the action of the other players. So the price high is not a Nash equilibrium. Price high, price low, firm A's action, firm B's action, not a Nash equilibrium. Then for the same logic, if firm A were to price low and firm B were to price high, notice that given that firm A is pricing low, firm B would like to change its action to price low and make 100 million instead of losing 50 million. So price low, price high is also not a Nash equilibrium. So that's how we do it. We'll do a lot of these. The correct answer was A. Both firms will price low.